So one thing that you might have seen when you're trying to learn the code or you're trying to jump into interviews is everyone keeps saying you should learn your data structures and algorithms. So they keep saying DSA, data structures and algorithms. And I wanted to point out the most important things I think you should learn as a web developer. There are a ton of different data structures and algorithms, but when it comes to web development, some of the stuff like, for example, Kruskal's algorithm or minimum spanning tree, these are things that you could learn for fun and they will level up your knowledge in terms of software engineering. But some of these are just not important unless you're building a very niche system that is really concerned about graphs and traversing graphs and maybe connecting different cities and towns and trying to find a way to like quickly drive between different places. But let's just talk about data structures and algorithms for web development. And I'm going to start with the easy stuff and then we'll kind of dive into the more like complex stuff. But again, I would recommend that you take time to learn all these and like in a sense, like these should be in the back of your head at all times of ways that you can basically solve problems. So the first one, definitely arrays, okay, or lists. You could say arrays and lists. And this is probably the first thing that you end up learning when it comes to web development. So an array, you have some things that you can just store in some arbitrary list. And with an array, you can basically create lists of things like tables in a UI. You can create entries in a reservation list or something. And understanding arrays just helps you in the front end and the back end all across the board. So I think this is probably one of the most important things to learn. With arrays, you should probably learn the map function, like have this thing memorized. Reduce is pretty useful as well. Filter, very useful. These are like the main three that you're probably going to end up using, where map allows you to basically take entries in this array and change them to another format. Reduce basically allows you to loop over the array and consolidate everything into a final form. And filter allows you to take stuff out of this array. Now, if you're using JavaScript, I highly recommend going and looking at all the existing methods on the array prototype. Like, for example, pushing something into an array. You have shift, you have unshift, you have flat map, for each. All these have their very niche use cases. And when you have these all memorized, or at least at the very back of your head that you can reach out for them because you have at a high level like what they do, it just makes coding a lot easier and also reading through code a lot easier. You can also reach out to Lodash. Lodash has a bunch of array slash object type of things. I know this one's a little bit more daunting. There's a lot of stuff here, but reading through all the methods and understanding their intent will make you a better developer because you understand that there's different ways to basically manipulate data to transform it into one thing, into something else, which you end up doing all the time when building out backend APIs, when building out front ends. Very important stuff here. Now, the second most important thing would probably be objects, okay? You should probably understand, at least in JavaScript or TypeScript, all the different methods that exist on objects. Some of the things that come to mind would be object.value, so you can actually get all the values of an object. Understanding how to declare an object, const whatever equals to name Bob, okay? It's important to know how to declare these things, how to change these things dynamically. So if I want to change the name from Bob to like, I don't know, Sally, you can do something like that. How to delete things from objects. So delete the name from the object. You can also say delete object.name. And again, this is also another one I would recommend just kind of reading through all of the things that exist on the object prototype. Like, again, I mentioned that there's object.values, there's object.entries, there's object.freeze if you want to freeze all the values of the object. There's ways to extend the prototype of the object to make stuff only readable. So getting a deep dive on like the actual syntax of objects can help you become better, especially if you're doing TypeScript or JavaScript, which is probably what I'm going to focus on because that's what I do on my channel. But when dealing with objects, typically, in a lot of languages like Python and JavaScript, an object is basically a map. So this is a data structure where you have the ability to assign keys to values. Okay, so you're mapping a key to a value. Now, when it comes to maps, they're very important for like doing performance optimization. So like think about if you have an array of like 10,000 things, and then you need to loop over and try to correlate that with other things as well. So what you could do is like loop over every object of your objects, and then you can basically put them in some type of lookup map. So say const map is equal to like some empty thing. Of course, you could say like new map. There's actually a map object in JavaScript if you want to use that. I'm going to keep it simple here. So you can say map object.name or object.id, and then you can map it back to itself. This is very useful because let's say you have another array you want to loop over. So this could be like, I don't know, parents, and this could be your children objects. Actually, I'm going to change this to pets. So one good example is like, let's say you wanted to add the name of the parent directly to your pets. Okay, so you're basically looping over all your parents and putting them inside of map so you can quickly, with big O of one constant time notation, learning big O is probably important as well. You can figure out a pet's parent or owner or whatever you want to call it inside of this second for loop. So like, for example, if you wanted to assign the parent name to every single pet in this pet's array, well, now you added that all to a map. So you can simply just say like pet.parentID is equal to something like this. Okay. Again, it's this type of stuff that really improves your code base versus like if you wanted to nest this for loop inside of here, and then you'd have to go and like loop over the parents to try to find the one that's matching by the parent ID. It's like not as performant, right? It's a big O of n squared versus constant time lookup, or I guess you could say like n plus p, depending on the length of parents and the length of pets. But I think you get my point. Learning maps and learning objects, very important when it comes to web development and data manipulation if you wanted to do it quick. Now, this is also important when it comes to caching. Like, I don't know, a Redis cache is basically like a giant key value store, which is basically a map. And understanding like how you use maps to really just increase performance and have faster lookups on things is just something you should probably have locked down if you want to become a web developer. All right, the next thing I'm going to do is stacks and queues. So this is actually very important when it comes to web development. A lot of times you're building it like a backend API, and you need to kick off a bunch of asynchronous processes. Usually you use something called a queue, where you'll just push in events into a queue, and then you have like a worker process that slowly pops things off or dequeues, processes it, captures it as done, and then eventually the queue will be empty of all this work that you have to be done. So queues are good for async jobs. Maybe you have to do like a fan out, fan back in type of approach, or you want to kind of limit how much work is in progress. You can have some type of like a P limit or a limit queue, so that you actually don't just flood your system with a bunch of jobs at the same time. You can kind of throttle them. Now, in terms of the data structure of a queue, it's basically a giant list. The only difference is that you add to the end and you take off the front, or vice versa. You could add to the front and take off the end. The point is that when stuff enters the queue, you try to process it in order. Now, there's different variations of a queue. Like, for example, if you're using like AWS Kinesis streams, like you will have to process these things in order. If you want to actually, like, let's say you're doing some type of video stream analysis, and like every part of this queue is a segment of a video, you definitely want to process these things in order. But you can find ways to basically do concurrent processing of the first three. Okay, so like I said, this is good for throttling. This is also good for debouncing, which you'll see in the front end a lot, where you basically want to do some stuff. And at the lower level, it's good to understand stacks and queues, because I mean, like, the whole memory management is basically a stack. So like memory is a stack and a heap. Those two data structures are what you need to understand when it comes to memory management. Now, with JavaScript and Python, probably not as important to understand. Now, I did talk about a queue where, like, you know, the order which things are added in, so like add and then like remove from the front. But a stack is a little bit different. It's still a list, right? So you'll still have like items, but the difference is you basically are going to push onto the front and you're going to pull off the front or the back. However, it doesn't really matter. Like, now, a good example of using a stack is like the undo / redo functionality that you might have seen on many sites. For example, when I do a Control Z, notice how it just undid what I did. If I do a Control Shift Z, it adds it back. They're probably using a stack where every modification of this canvas is pushing a command onto this queue, so that when I do a Control Z, it basically looks at the last command that was done and it finds a way to basically revert it. And then it probably pushes that onto another stack. So like that 4 would be popped off, probably put over here onto a different stack. So if I do a redo, it'll take the 4 and push it back over here, right? So it's like the little data structures and algorithms like stacks and queues that help you implement various features in your code base. So just understanding how they kind of work under the hood is probably a really good understanding. And eventually you're probably going to end up bringing RabbitMQ or Kafka. That's basically a whole message broker, which is built up of a bunch of queues and topics. That's a whole nother story. That's more like system level design, but just understand that it's a queue. You push stuff onto it and the stuff gets kind of processed in order, assuming how the concurrency is set up for the processing. So the other thing you should probably learn is a set. This is a way to keep track of unique values. So keep track of unique values. So typically a set, denoted like with, you know, curly braces from what I've seen, you can just push things into it. But the caveat is that whatever you push in, you can't have duplicates. So this is really good if you want to track if you've already seen something. So you'll push something into a set, and then if you've seen it, you don't want to do some operation again. So again, a set is useful for tracking uniqueness. So like one good example I've seen in a web UI is basically you wanted to display all the characters in a word. Some words have, characters duplicated. So for example, apple, or if you had like a large sentence, let's say you wanted to create a histogram of characters. Well, you could probably use a set, and then at the very end, your set would be APLE, and it would kind of like get rid of that extra piece so you know that these are the actual characters that exist in the word. That's a really kind of simple example of a set, but usually it's used for like performance things and speeding stuff up. Just so you can do a quick check to see like, hey, is this person like a member of the company? Instead of having to loop over a giant array to check that, you just check the set and it'll tell you true or false if you exist inside like a membership or something. Okay, another one that's important is trees. When it comes to web development, whether you know it or not, the entire browser is built up using something called the DOM, which is basically a giant tree. You have like a root node, and that root node maps to other DOM elements, right? So like you'll have the root node will go and have many children, and those children have more children. If you ever use React and you try to nest multiple children inside of a tag and it complains about like you can't have nested children in a root node, behind the scenes, most of these frameworks like React and Vue, where you have components that are made up of other components, it's basically a giant tree. Out of all the data structures, like this one is probably the most relevant for web development because we do a lot of tree stuff when it comes to the DOM. But I will say in practice, when building out web applications, you don't really use trees too much unless you're building like a niche piece of software that like needs to build up some type of tree object. So when it comes to a tree, typically you have like a root node like this, and then the root node can have children nodes. Okay, so like array of children. And then inside of all those things, again, you're going to have like objects, and those objects can have more children. And it kind of just goes deeper and deeper recursively. And so this is the main reason you should kind of learn about trees, is because if you look at an object that's nested like this, traversing this to find certain things is basically just doing some type of like depth first search or breadth first search. So there are algorithms you should probably look into: depth first search and then breadth first search. I think I spelled that right. These are two tree/map traversing functions you should probably learn so that you can actually like write code to traverse this type of object, or like, look through all the different nodes of your data structure so you can find certain things. Again, this is important to learn. And also I'd probably say graphs. So like, again, now a tree is a type of graph, but like when we say graphs, you could have like a person, Bob, and they're friends with like a bunch of other people. And then you could actually have this person have friends with other people like this. This person may or may not be friends with that person. So Bob, I'll say like Tina. And so like a graph is really good for web development because if you imagine like a social media network, that's all based on graph, like friendships, following. Anytime you have a thing that points to another thing that can point to another thing, and that could potentially point back to itself, maybe not. You want to kind of understand graphs. And again, depth first search, breadth first search. And there's other graph traversal algorithms you may want to learn, like A star if you're trying to build out a game with AI. Maybe you should kind of look into that. But again, this basically boils down to like you'll have some type of thing that has like an ID that references another thing. And so you need to write an algorithm that kind of loops over or traverses these objects until you can find a particular friend with a certain name or something. So just learning graphs, I think, very important as well. All right, sorting. Now, when I say sorting, I don't mean like actually learning how to implement quick sort or merge sort. I'm talking about like just the practical applications of sorting. Typically, when you're building out a web application, often you have tables, and every column in that table need to be sorted. Sometimes you have like a multi-sort functionality. Granted, there are third-party libraries that kind of take care of all this for you, but understanding the concepts of like, you have a sort function, you have an array of a bunch of different elements or values, and often we want to sort them in a particular way so that the user can quickly find what they're looking for. Now in JavaScript, you typically like have a sort function. I would probably just use the built-in sort function. It's fast enough. And then in here, you basically have to return some type of, I don't know, value minus some other value here. So this is the simplest approach for like sorting. And granted, the dot value is probably not the correct example here. I should probably just say A minus B. And that's going to sort it in a particular direction. You can actually swap these, and that's going to sort it like ascending versus descending. So having a good understanding of sorting and why you want to do it, because again, in web development, often you'll have to fetch things back from a database. Let's say you're using SQL, you got to add a sort statement. And then you have to do pagination that also relies on sorting. In the front end, you typically have tables and lists that you have to sort. You have to order things alphabetically, reverse alphabetically. This is a very important one to do. It's not too hard to just do a dot sort on stuff, but understanding the logic that you put in here and understanding like how a sorting algorithm kind of works. Like, yeah, maybe you could spend a couple days like learning selection sort, but I would not waste time like learning merge sort and selection sort in bubble sort. Like it's just a waste of time in my opinion. Just find a library that does sorting for you and move on with your life. Recursion is another one. I'm actually going to put recursion over here. I'm just going to say like plus recursion because typically traversing these trees and graphs, like using these recursive algorithms can be kind of useful. Some other algorithms, debouncing, definitely important for the front end. Like often when someone's typing into an input box and you don't want that to keep on making tons of requests to your backend, you want to wait maybe 100, 200 milliseconds until the user stops typing, and then you can go and fetch the data and then display it in a type ahead panel or something. I'm sure you've seen that a lot where, like for example, YouTube search, I can go ahead and type in, I don't know, I'll say approach, wait a second, and then notice that it does a search. That's a debounce. Notice there was a delay, and then we got some data. I will say that YouTube's debounce is pretty fast. Like you'll notice that you'll get results pretty quickly. But knowing how to implement that and why you need it, probably important to add in. Also, memoization. So memoization, this is a performance thing, and like you've probably seen use memo in React. This is a way to basically prevent the React framework from like rerunning a bunch of complex code. Basically, it's a caching mechanism, right? So like if you've already run it once and it takes 10 seconds to run, cache it somewhere in case someone else tries to call it again. And you know the arguments for that thing hasn't changed, just return the value. Now, when it comes to caching and memoization, you should probably learn a little bit about cache and validations, like least recently used. There's other things out there as well, but like just have a decent understanding of like I don't know, maybe you need to bring in Redis and you need to understand a little bit about caching there. It's probably important there. Big O notation. This is something that, you know, people always say that you should learn. I think at a high level, you should be able to pinpoint an algorithm that looks kind of, you know, slow. So for example, going back up here, when you see a for loop that's just looping over a bunch of objects, that's just O of n, right? Just looping over a single thing. But if this was actually nested inside here, this would be of potentially n squared. Now, not in this particular example, but like let's say you had for let O of map, and then you did that again for let J of map. Right? You can tell that this is going to do a double for loop. So it's going to be O of n squared. And I think just understanding your code a little bit better and identifying when there's stuff like this, and then also knowing when this is going to be a problem. This really only becomes a problem when like n is, I think, like 10,000 or like 100,000, because it ends up getting like 10 million operations. And then this stuff could take like a second to run, right? So when stuff takes a second to run, then yeah, maybe you should find a different algorithm. Maybe you can bring in a map or a hash or some type of performance algorithm to not have to do this. Typically, if possible, you want stuff to be O of 1 or O of n. Sometimes you want to do like, you know, n of log of n. But O of n squared can be pretty slow, so just be on the lookout for that. And there's also like even slower big O notations. I wouldn't focus too much time on this, but just getting good at identifying when a piece of code is just looking like it's going to be slow. And on that, like you should probably learn your debugger. You should learn how to do like a flame graph, so you can actually like analyze which components in your React code base or what components in your, I don't know, your game engine are taking the most time. And a flame graph is a great way to visualize the memory usage and the CPU time of your functions. Now, some additional things that you might want to look into. Again, I am using an LLM to kind of give me some suggestions. So like if you go and Google this same topic, you're probably going to get an output similar to what I'm teaching you guys. But there's heaps and priority queues. We already talked about queues, but a priority queue, basically you are allowed to attach a priority number to these things. So imagine if these are actually objects, like, you know, people objects, and someone has a premium membership. You can put them at the top of the priority queue so they get their work done first. Imagine if you're trying to do some type of like online AI image generation, and you are a premium user, you want to get to the front of the queue every time you make a request. That's something that you can do with a priority queue. A heap is a type of data structure that basically like self-organizes to make it really efficient for doing lookups and writes and stuff. So just understanding the heap algorithm. I've never used a heap in like my web development career before. I think it's more important for like computer science type of stuff, or if you're building out like a database. Yeah, probably understanding a heap could be useful. But again, I would not like prioritize like understanding how to implement some type of heap. Another interesting data structure is a tree. This is like a prefix tree. This is useful for like if you wanted to do some type of like type ahead lookup. So for example, going back to the YouTube example, let's say we had like a bunch of data locally. The moment I type in O, I want it to quickly filter down and give me all the results that live in O. So if you were to look at how a tree is kind of set up, you'll notice that is basically you have like a root node and then you have all these characters. So for example, I typed in O. You can learn how to traverse this path to find all the things that have O as the first character. And then as the user types the next character, you can then filter down even more, like what are the relevant words that make up, O and then N. So using a tree structure, I think it's called a tree or tries, I don't know. I think it's kind of important to at least understand the point of it. I think at least knowing this could be kind of useful for like certain things like type aheads, autocompletes, search suggestions. But yeah, overall, like I think I might just get rid of heap, honestly, just priority queue. For web development, priority queue is something I've seen in practice. A heap, probably have not seen that in practice. This is something I've actually seen in practice before. Like you want to really make something fast for like quick lookups, you can learn those. All right, so there is a decent sized list of things. I would probably recommend at least knowing the things at the top and the things I started with are by far the most important. Like arrays and lists, you use all the time in web development for looping over stuff that comes back from the database, doing data manipulation. Objects and maps, like you should have these two, like the whole standard library, like you should have every method that exists on it probably memorized if you want to become a good web developer. Stacks and queues, definitely important. Sets are important. The trees and the graphs, they're less important. Sometimes you'll get like an interesting thing you have to implement that requires a tree or a graph. But I would say this is more important when like doing game development or, having AI do pathfinding. For building out like a CRUD application, I've never actually seen this be used. I think understanding this is probably good if you're trying to build out your own Vue or your own React framework. Then yeah, you should probably understand trees really well because you're going to be doing a lot of DOM manipulation. Sorting, this is actually probably more important. I should probably put this up here. Sorting is probably really important to at least understand and when it's practical to use. Debouncing and memoization, this is also important. I'm going to put it near the top. Big O notation, not really important. Just know when stuff looks slow. And then this stuff, could be useful. Anyway, if you guys enjoyed this little overview and you found this helpful, let me know. If you did not find it helpful, let me know. Just trying to branch out, get back into making videos again, try to teach more what I can, and I'd be open for any suggestions. So leave a comment if you have a suggestion on other stuff you want to see me make a video on. Other than that, have a good day and happy coding.